Yes, we're recording it and we will be sharing it later. Yeah, so we're live now. Hi, everyone. This is Xibei from DoraHacks. Thank you all for joining us today for the WebNOVA Space App Hackathon Demo Day. This hackathon is organized by Exodus, Obitus, and at DoraHacks, we are very glad that we get to support this exciting hackathon. So yeah, today we have Dennis Silin, the founder and CEO of Exodus Obitus, joining us. And we also have Esteban Diaz-Lais with us today to demo his winning project. His project used machine learning to find planes on a photo acquired from WebNOVA APIs. Before we kickstart the session, just let me give you a quick introduction about us if you don't know DoraHacks well enough yet. So DoraHacks is a leading global hackathon organizer and a developer incentive platform. We love to support innovation in space tech, quantum computing, blockchain, and many other frontier tech fields. To date, we have supported 8 early-stage projects working in the space sector with our ongoing long-term space resources and exploration grant. So everyone building within the space sector is welcome to participate and receive support from us. And more excitingly, we launched another bigger initiative in October to further foster space tech innovation, which is our Starship Use Cases Hackathon, with $100,000 in prizes, considering the vast potential of space exploration offered by Starship's heavy lift capacity. We have developed 18 use cases and 2 open challenges for hackers. Use cases include orbital hotel, space farming, routers for global Internet of Things, metals from the moon, etc. 2 open challenges are novel satellite constellations and recreation facilities for space hotels. So through this hackathon, we like to motivate all space enthusiasts with engineering skills to build their solutions for space. Yeah, so feel free to check out more details through the links below in the description. So yeah, that's a bit of an introduction about DoraHacks. Back to WebNOVA Space App Hackathon. I know that the Exodus Obitus team has received some pretty impressive results. So Dennis, would you like to say a few words about the general quality of the submissions and some of the highlights of this hackathon?
Thanks, Xibei. We're definitely impressed with all the interest that came from all the developer community on DoraHacks. We got about 40 developers signed up for the hackathon, and we had, for the first try, just two challenges, basic and advanced one. We had the winner, Esteban, who was able to solve both challenges successfully, and that was just the first try at our hackathon. We plan to host another one later in 2024, and we have a lot more challenges, and we plan to attract a lot more developers. We had some I would say attempts, and I like the effort that was showed by all the developers. But definitely the challenge we offered, the second, was quite advanced, and not everyone was able to solve it. Now, the results exceed our expectation, and Esteban can talk later about his winning app. We plan to use the same approach with real apps in space, and the whole idea is that we will make developers to be able to build and launch the software applications to run on the satellites, Earth observation satellites in space, and that's entirely new domain of application development that was not possible before. We want to thank our sponsors, Cytospace and Copernic Space, as well as another company who helped us with broadcasting the message and attracting more developers. We plan to invite more participants for the next occasion. And our third sponsor is Deva, the company that's providing solutions for software development projects. And we are currently awaiting the prizes for the winner to arrive in our mail, and we'll send them as soon as we get it. The prizes include the MicroNova CubeSat simulator and the ability to send a megabyte of data to the moon, as well as the big prize, which we plan to arrange for the end of the next year to launch your app actually into space on one of the satellites from our partners. And to add one more thing, we also plan to participate in the Starship Hackathon, and we're working on one of the use cases, the orbital hotel, and we'll announce what we'll present later in December.
Sounds very exciting. Thanks, Dennis, for sharing all these details. And I'm really glad that you guys received impressive results and you're planning to do another one in 2024. We're really looking forward to it. And it's so good to hear that you're participating in our Starship use cases hackathon as well. Really looking forward to that as well. Please keep us updated about your progress. Yeah, so sounds great. So next, let's welcome Esteban to do the demo of his winning project. And after the demo, it'd be great if Dennis could give some feedback. And for the audience during the demo, please feel free to share any questions you have in the YouTube chat room. I'll make sure to ask Esteban your questions at the end. Yeah, feel free to take the mic, Esteban.
Okay. Hello, everyone. I'm Esteban. So I will present my solution to the first two challenges. The first challenge isn't very difficult. It's just to get data from an API that Exodus made, and it's fairly easy. You can make it in Python, in TypeScript, and I choose Python. I will share my screen so you can see the code, and it's right there. Okay, I don't know if maybe the font is too little. Yes, better like that. We'll just check it on the live stream. Yes, it's nicer. So it's just an API call for this latitude, longitude, and this time. And with that code, you will obtain an image from the satellite. I've just taken it right there. And that's the image. Okay, so the challenge 2 was you have to find the planes in the photo. So the first question I asked Dennis is, what plane on the photo? You have to make a very good zoom to find out that they are there. So the main problem in this kind of photo from satellites is that planes are very, very little. In this case, 10 by 10 pixels, some less. So if you want to do it with OpenCV, for example, it will be very difficult because you don't have too much data to feed it. So I've done another thing. So I use the machine learning to make a model to recognize this kind of planes from a satellite view. So how do you do it? It's not that difficult, but really the problem is the data. You have to have some photos with already planes in it that matches this kind of satellite views. So the first thing I did is take some data and make the simple CNN model. The simple CNN model is right there. I will show it to you. Maybe I'll change 1, change 2. So yes, it's a basic model. So you can make it, for example, with TensorFlow. I've trained it with Google Colab, so it will be it will be quicker to train, and the results were fairly good. So the result you can see in the end of this Python, this Juniper notebook. They are right. So when training, and the last training, we have a fairly high accuracy between 98 and 99%. But the problem with this type of accuracies is, yes, what do you detect with this accuracy? So it detects only that this kind of photos are or are not a plane. And here it's a plane. Yes, I don't see a plane here, but the ML sees a plane here. So fine. The other problem is that our photo is fairly big. So how do we do something that is 10 by 10 pixels? Well, in the data, it's 20 by 20 pixels, but okay, you can reduce it to 10 by 10 pixels. So the first idea is, okay, so I will just take 10 by 10 pixels in my photo. And the original photo is fairly big, so it will take a long time. And it doesn't guarantee you will find planes. So the other approach was to use a fast RC CNN model, and that's I've done in this one. So the fast CNN model is it's not very big. It's only 300 megs, but to train it, you have to do it with Google Colab. I will share my screen. You can use the free Google Colab. I'm sharing my screen. Yes, right there. You can use the free tier GPU or TPU if available. And when you train your data, what you obtain is that it can detect planes on this kind of photos. These kind of photos are fairly big compared to what we have because they are 600 by 600, but it should have a fairly good results. And also this model is 300 megs. It's not too big, so I can do it with my laptop. When trained, I can run it on my laptop. Back to the code. So nice, we have that. I've prepared a Juniper notebook just for this presentation. So the final results are not that bad, but we can make it there. So what you have to, once you have all the ingredients, the first thing is to install everything. So I've already done that, so it will be very quick, maybe 5-6 seconds. And you can see my GPU isn't very high spec. It's just a laptop MX 150, and it has only 2 gig of RAM. So it's nothing that anyone can have. So once everything is installed, take a little longer. I will just run it through. We configure a model. The model is a fast-RN CCN. And we will see the results for the challenge image. Okay, for the challenge image, but I've only taken the center part, which is 250 with this eighth and width, and the results. Okay, if we take photos of this size from the original photo, it's this partition. The results with that were fairly good. So we can detect airplanes that have 10 by 10 pixels. There are some other problems. For example, I have a very low threshold to detect this kind of airplanes. So why did I take a very low threshold of 30%? It's just because this model will only be used to have a region of interest. The first model will say that this is a plane or not a plane. So I don't have to seek for planes on the whole photo, but just only on certain parts. The rest of the code is doing that. I forgot. Does this work on high resolution images? Yes, and very good, very well. For example, Dennis gave me this image, and you can see we have a very good results with high resolution image. This is a very small one, and with the bigger one, we have also very good results. The threshold for this one, I think the threshold is 80%, 85%. So very good results with high resolution images, but the challenge was where with very small planes of 10 by 10 pixels. So we will try that. Okay, so the next part and the last is, since we have some region of interest, we will check that each small box we have is really a plane. This code does that. It just runs the models over the photo we have earlier with a very low threshold and checks that it's a plane or not a plane, simply by taking the pixels and feed it into the simple CNN model. Once we have that, we draw an image to see if the plane really has done this. I will just run the code. So we have the final photos. I will just show the photo, the final photo. It's not very relevant. Yeah. The final result is that in red, these small red dots, I will just make a zoom, are where the fast RCNN model checks that, yeah, there is a plane. Yes, it checks a plane right there, but with a confidence of 33%. Once you have passed the CNN model, it will check if it's a plane or not, and this is the final result. So every green checkboxes is, yes, this is a plane, and the red one is the bigger model that that work very well with high resolution images, but not with these low resolution images. And that's how I solved the challenge number 2. And that's all for the challenges.
Thank you, Esteban.
Yeah,
that
thank you,
really
Esteban.
impressive.
Yeah. Yeah, Dennis, could you please share with us and with the audience, like how, as the perspective of judges, how do you evaluate the project, and what are some of the highlights of Esteban's project?
Yes, so we evaluate on both the effort and the result. As I mentioned, people made some progress, but Esteban made it all the way to the end and presented a coherent solution that was able to solve the challenge in the most convincing way. You can see his presentation detects the airplanes, even on the low resolution photos, works well with high resolution. And it is what we want to launch into space pretty much. Now, the number of submissions were like small enough for the first time, but for the next hackathon, we want to have 10 times as many developers and probably 10 times or 5 times as many challenges. So there will be a more gradual difficulty curve. In the first one we had very easy and very hard. In the next one we will have more gradual difficulty curve for the developers, so it will go from easy to hard in a smoother manner. That was kind of big most important feedback from the first hackathon, from what developers told me.
Sounds good. Yeah, thanks again to Esteban for the great demo, and thanks, Dennis, for elaborating more how you evaluate the projects. And I see Max joined a little bit later than us. And Max and Dennis, why don't you take this final chance to share with us more about your future map at Exodus Orbitals, your next steps, etc. Because if Max has something else to add on to what Dennis shared earlier, feel free to shoot.
All right.
Thank you.
Yeah,
Thank you so much. Just 5 cents from me. I apologize that I can't have my video on. I'm commuting to London right now. But first and foremost, I would like to thank Esteban and other participants who took part in WebNOVA, the first annual space hackathon that Exodus Orbitals hosted. We were really impressed by the efforts every participant put in, and huge kudos to the team that made this possible. DoraHacks, Dennis and engineering team at Exodus Orbitals. It was like a big effort around the clock, not only during the hackathon, but before and after it. So this is the first step, and we are very impressed with what the participants were able to achieve. So thank you.
Yeah, thanks. Thanks, Max. Anything else to say, Dennis, before we wrap it up?
Yes, again, we want to advertise our platform in the form of hackathons to the global developer community. If you're tired of doing the same thing, be you a web developer or a mobile developer or desktop, we can give you an opportunity to solve problems in space and create apps similar to the winning one today, and just launch your code into space. That's our grand vision, and we hope to execute on that coming next year.
Sounds exciting. Yeah, sounds awesome. We're very much looking forward to Exodus Orbital's progress in 2024. So for the audience, if you'd like to know more about this winning project of Esteban or WebNOVA Space App Hackathon in general, feel free to explore more through the links in the description, or go to Exodus Orbital's website to check out more details. And in the description below, you can also find links to DoraHacks space-related grant and hackathon programs. The submission portals are open, so we welcome you to join us anytime you're ready, and we can't wait to review all your submissions and provide our support for your projects. With that being said, I want to say thank you to Dennis, Esteban, and Max for joining this demo day with DoraHacks, presenting the great demo for WebNOVA challenges. Really appreciate your time, and thank you to all the audience for tuning in today. We do have more space-related content prepared for you, so make sure to follow us on Twitter and YouTube at DoraHacks, so you won't miss out on any of the upcoming live sessions or any updates of our initiatives. So yeah, thanks to you all, and we will see you soon. Have a great one. Bye-bye.
Bye-bye.
Bye-bye. Thanks to DoraHacks for helping with the hackathon.